This is an experimental study and proposed theoretical solution for the prediction of ductile or brittle failure modes of reinforced concrete beams strengthened with external steel plates. Our study conducts an experimental study on the rupture mechanism of the plate-strengthened RC beams and proposes a theoretical model to predict a crack formation, the distance between cracks, the plate stress of rupture, and the failure characteristics of such systems. 7 identical RC beams were fabricated based on the given dimensions below. The first beam is D0. The 6 remaining beams are D1 to D6. The loading force, beam displacement, and strain are recorded simultaneously based on control software. Test results and discussions. Our results are presented from Figure 6 to Figure 9. Our observations include: 1. The strengthened beam stiffness has been significantly enhanced compared to non-strengthened beam. 2nd, the strengthened beams generally have lower ductility than reference beam. 3rd, the beams are observed to fill in the form of ultimate flexure strength, not by shear failure modes. Crack distances were measured using a grid line drawn on the surface of the tested beams. Although all the beams with external steel plate were identical, the crack positions, crack distances, and the positions of plate delamination are random. Since initial delamination occurred at one location, the failure of RC beams initiated because of the external steel plate would not contribute to beam persistence. Our assumption is, when delamination occurs, the external steel plate does not contribute to beam flexural resistance. Therefore, delamination is due to peel off or slip off concrete near steel plate. By developing the tension cord theory for RC beams with external steel plates, the maximum and minimum distances between consecutive cracks under flexure can be determined as below. This is the formula in which a coefficient defines the ductile and brittle condition. Given this information, the similarity between our experimental results and assumptions validate our proposed theories. Our conclusions are: 1. Steel plate separation is random. 2nd, our theoretical model is relatively simple and is very efficient in predicting the brittle ductile failure mechanism of the steel plate strengthened RC beams.